This video is to go over building Java programs, chapter 14 on stacks and queues, exercise 14.1 split stack. And we are we're supposed to split a stack. Here's a stack, the input, and we're supposed to split it so all the negative numbers go first in any order, doesn't matter, and then all the positive or non-zero numbers come after that in any order. And they don't give an example here, so this is really important to take a look at what you're doing. And the key here is that they say you can use a single queue as auxiliary storage. Whenever they say you can use something, that means you really probably need to use it. So think about how we can do this. So if we were just not using data structures at all, I would just walk down this list and I would find any items that are negative, and I would swap them back probably to the beginning. It would take a couple of pointers keeping track of where to swap them to and where I'm at. Now with the stack, we don't have that flexibility. Well, the only flexibility they give us is a queue. So we have to think about how can we use a queue to do this. So we've got to take all these negative numbers and put them at the front of the queue. So that should give you, or the stack. And so that should give you an idea that maybe we need to use that queue as a temporary storage for doing that. We started out in a stack. And so the only thing we can really do is we could pop stuff off the stack. We would start here and we could pop them off. We would pop a 6. And we need to get that 6 into the stack, but we have to get all these negative numbers first. So if we just have a stack, we can't really do anything. We can pop them off, we can push them back on, but we can't really reorder them. If I have the queue, I could pop off the 6 and I could put it into a queue, and I could pop off the negative 12. And then so I've saved the positive numbers. Now I got a negative 12. What am I going to do? I put these in any order. Yeah, it's confusing as to how to do that. After looking at this problem enough, you should realize that what you need to do is you need to really get everything into a queue to start. The queues are kind of magical data structures for these queues and stacks problems, because there's a nice property of queues that while you don't have direct access, you can actually cycle through this queue. You can pull off things from the front of the queue here and then add them to the back. And you can go and, for example, you can sum up every item in a queue just by pulling them off, adding them, and putting them back. And you can do a filtering operation too. You can pull off every item in the queue and only certain items you put back. So we can use that property to actually filter these numbers for negative numbers, take all those out and stick them into a stack. So here I've got a data structure example. Here's the queue that we are going to start with after we transfer all these items. It's going to transfer them in reverse order to the queue. So this is the top of the stack, and it's going to start putting them at the front of the queue and then adding this way. So we start off with that, and then we're going to go take each number in turn, 6, negative 12. Whenever we find a negative number, we're going to remove it from the queue and put it in the stack. All the other numbers, we actually do remove all the numbers, we just have to stick them onto the back. So we're going to pull this 6 back there, take the 12, put over there, negative 12, take the negative 1, take the negative 8, and throw this 12 on back. And we're going to end up with this view here with the queues of all non-negatives and the stacks being negatives. Then all you got to do is just transfer all the items from the queue to the stack. So let's take a look at some pseudocode that will accomplish that. So first you're going to transfer everything from the stack to a queue. Then you're going to loop the items in the queue. You have 2 choices for each item. You're always going to pull it off. But if it's negative, you're going to push it onto the stack, because that's where that's the way we want it when we're done. If it's non-negative, you just stick it back onto the end of the queue for processing later. So and then finally what you're left with, the stack has all negatives and the queue has only non-negatives. And then what you're going to do is just pull off every item in the queue and stick it onto the back of the stack. So it's going to look like this. Now I'm not going to show you the code, but what I'm going to do is I'm actually going to drop into Eclipse and show you what the code execution looks like. So this is Eclipse, but I'm using a visualizer made by Adam Blank, a former lecturer at the UW. I'm not going to show you the code, but I'm going to step through the code. So what I've done is I started out with an array of data, and then it's been transferred already into a stack here. So here's our stack. The way that Adam visualizes it, the stack top is at the top, like a stack of pancakes or something like that. Normally this top would be on the right-hand side of things. So we're going to go ahead and let's see what happens here. So we need to create a new queue. That's the temporary queue from this stack. So it starts out as empty, and then what we're going to do is we're going to take off each element of the queue, of the stack. We're going to take off this 6, and we're going to push it onto the end of this queue. Okay, so that's one item, and I'm just going to skip ahead until we'll do one more item. So the -12 will end up here. Now I'm just going to skip ahead, and it's going to transfer all those items. So the stack is now empty, and here's the queue. Now this stack is what we're going to eventually return. It's got to have the negative numbers put on the bottom of the stack, the positive numbers on the top of the stack. So we're going to use this queue, and we're going to cycle through here. I'm going to start stepping through code. You can't quite see what's happening, but I'm setting up a loop here. I'm checking the length of I'm saving away the length, because as I start removing things from the queue, the length is going to change, and so I don't want to lose that. And then I've got an index variable, so we're going to start with the grabbing the front of the queue. I've already pulled off the front now, so the 6 is now in this variable front. And let me just show you, scroll back up here. So this is the data array that I started with. So there's the 6 and the -12. Okay, so I'm holding on to 6, and now I have to decide what to do with it. So positive numbers I don't want to stick on the stack yet. I need to return them the negative numbers first. So I want to put it back. So I'm going to put it back at the end of the queue here. So in just a second, it'll appear as a +6. There it is. Okay, and let's do one more loop. So I'm going to grab the second item, which is going to be this -12. Okay, there's -12. So now I have to decide what to do with this. So negative numbers, we actually want to stick on the stack. So it's going to get stuck on here. One more execution. There it is. Okay, now I'm going to go step by step. So -1, that is going to end up on the stack. And I guess got to press it once more. Okay, there it is. -8, that'll end up on the stack. 12, that should go put back to the end of the queue. 5, that should also go to the end of the queue. -3, we should put that on the stack. 2, that should go to the end of the queue. Now it's hard to see from this, but this is the last element of the array that we started out with your initial. So this is the last item we're about to process. So this 14 is going to end up back here. Okay, so we're done with the first phase. We've now transferred all the negatives to the stack. All the positives are still in the queue. And from here, it's a pretty easy operation. All we have to do is just start pulling off items from this queue. So we're going to pull off this 6 and then push it onto the stack. Same with the 12 and then the 5. Let's see if I can skip ahead. There's the 12, next the 5, then the 2, the 14, and we're done. So and then all we have to do is just return this the stack, and that will meet the problem requirements. So that's how the code looks like when we execute. So you have to figure out how to translate that into exact code, but it should be fairly straightforward based on this pseudocode that I gave you here. So if that's been helpful, please like and subscribe.